This is the board that we are going to learn about. It is a C2000 series board. Basically, we have ordered some board and it is yet to come. But when it will come, we can have actual overlook of it. So it's something looks like this. So it is a TMS320F28379D board. So this C2000 microcontroller can be used for different purposes. It is everywhere actually. Whenever there is microcontroller, it can be used for any automotive application such as electric vehicle, robotic application, ranging from your cars to your batteries, from your vehicles to your TVs, and from your automatic washing machines to electric bikes and everything. It is everywhere. So why this microcontroller is so much in use and why we are so much eager to learn about this microcontroller is that one of the biggest advantage of this microcontroller is that it can have a separate core CPU which is used for handling of your different equipment, such as everything, as you know, in this world work on a clock pulse. If you have something to go on, you must be aware about any pulse signal that we usually see. It is a step signal, high and low signal. So everything that works on this world is basically depends on clock. So whenever you give any high clock signal, it will be on. Whenever it will be low clock signal, it will be off. So this is the same kind of device which works on a particular clock. Okay, so the clock frequency of this particular board is 200 megahertz. So the front view of this board is somewhat look like this. You can see these are the some. This is one oscillator over here. This is another oscillator over here. So this oscillator is used for providing the clock pulses to your particular microcontroller IC. So this is a dual core processor which is having CPU 1 and CPU 2, which are of actually 32 bit. So what 32 bit means, you can imagine it as like 32 lanes in a road where actually 32 vehicles can pass at a time. So what it actually does is, let's say you want to transmit per one clock cycle, you want to transmit certain amount of data into a microcontroller. So it can transmit from 0 to 2 to the power 32 for any unsigned integer bit, and there is one thing called as signed. So all these are signed for that means you can range it from negative 2 to the power 32 to positive 2 to the power 32. So this much of the integer data can pass in one clock cycle. That is the meaning of one particular 32-bit microcontroller. So this dual core CPU, it can actually operate using CPU 1, either CPU 1 or CPU 2, or both CPU 1 and CPU 2 you can use. There are different, actually all the timers, program bus, data bus and registers, everything is different for both the cores. So you can independently use them or you can concurrently use them together as well. There is one more processor which is known as control law accelerator in this particular microcontroller. We'll see the use of all these processors, how we can actually use them, and what is how you can use them parallelly as well if time permits. We'll look into that as well. Okay, so this is a basically microcontroller that we are going to learn about. So you can see here there are actually 20 set of pins like J1, J2, J3, J4. This pointed knock, if you can see, it is the same pins which are there on the back side as well. And I have shown here some banana connectors. These are used for integrating your these wires, whatever banana wires you are seeing from the back side. These are male to female connectors I have given you. So these female connectors you can insert into this particular black holes, and then if you have a male connector on the other side, you can connect it to the scope as well. So what these pins are? These pins are named as J1, J2, J3, J4, J5, J6, J7, and J8. So these are the certain connectors. These connectors are what these pins are actually. These all pins are GPIO pins. That is general purpose input output pins. You can set it this pin as an input output. How we can set all these pins, we'll look into it. For now we just have to see how the architecture of this processor is and what are the useful pins for our use. So this was the overall look of this, and this banana connector, this can be male to female. If it is female to female, what you can do is, if it is female to male, what you can do is you can insert into this pointed pins are there. In this pointed pins you can insert your female part of banana connector, and this male part of banana connector you can connect it to the oscilloscope. Now when you have this other portion, black portion, these are for connecting your pointed pins from male connectors, and if you have male to male connectors, you can connect it to the scope. So whatever pins are there on this side of the board, same pins are there on the back side of the board as well. And you can see there are certain things written on the side of this board. These are actually the pin numbers like J1, J2, J3, J4. So these are the 8 sets. like 1 2 3 4 5 6 7 8 8 sets are there, and you can see 10 sides, 10 pins on one side, 10 pins on other side. So every pin has certain number which is written on the back side of this board. It is also written on the front side which pin number is there, so that it should be user friendly. That was the main motto of this. So this is the overall board overview that we have here. Okay, and you can see over here, there is one XDS 100 version 2 something is written on this front of this board. This is actually your JTAG emulation cable, which actually the range of this cable, what cable you are going to connect in order to power up this board. See, basically every processor works independent of your PC system. Okay, it has its own CPU, so it is not related to your system, like what software will support, what kind of processor will support, it should be 32-bit or 64-bit. Okay, that won't be dependent on all this kind of thing. Okay, so this board just need an external 5-volt supply in order to power it up. Once this board is powered it up, it can actually operate on its own. So there are certain extension boards provided in order to give that 5-volt supply, so that you don't need to connect it to the laptop every time. Then you can just, if you burn your code into flash once, you can actually use it later without repeating the code on the same time, or you don't need software in that cases. So you just have to burn your code onto this particular microcontroller and it is good to go. It is like that. That's why it is used everywhere, such as electric vehicles and everything, whatever the applications, as I told before. So this was the board overview. Now, Texas Instrument has provided lots of materials on this particular board, but everything is little bit ambiguous. Like little bit ambiguities were there when you're going to learn this board. Certain formulas will not work properly. Certain registers will not work properly. So how to program them actually, that is a big deal. So we are going to learn everything in this course from top to the bottom, what is exactly into this particular board and how we are going to code it. Okay, so this particular board has provided with different set of peripherals. Okay, different set of peripherals in the sense you can say it has EPWM peripheral, it has equip peripheral, it has ECAP peripheral. So these are all provided for users helping in the way you can say that, let's say you want to generate some pulse. So for that you can use EPWM peripheral. Let's say you want to detect the position of the motor, particularly if motor is running, certain encoder is bounded on the shaft of that rotor, and you want to see what is the position of that particular rotor, so that you can perform your mathematical computation inside. So that one is given through equip module, enhanced quadrature encoder pulse module. So if we get some time, we'll also look into little bit of this peripherals, how they are going to work, what is exactly. Actually, TI will provide you each and every algorithm for this, but you should be able to know how that algorithm is working. Then only you can make changes into that algorithm. Otherwise it becomes very difficult and tedious to learn this particular microcontroller. Like first of all, into this course what we will see is little bit about C background as well. Like you need to know about functions, little bit about pointers, how functions work, little bit about pointers. Generally when we are using this particular microcontroller for coding, there are two types of coding available in this microcontroller. One is driver library and another one is bit filled. So we are going to use the approach of bit filled, since it is easy, because every register you can program it bit wise, and you can see what will happen if you change into that particular bit. Okay, so that was about the coding part that we'll see into the that we'll look into the later. So first of all, what we have to see is this is the board, and there are different peripherals, pins, and all the pins are GPIO pins. You need to remember just one thing in all this board, that whatever pin you are going to use, it's a GPIO pin. GPIO stands for general purpose input out. Okay, so you can use that pin as an input as well, and you can use that pin as an output as well. What actually that means, that we'll see in the later slides. Okay, so I guess this is clear to everybody. Is it clear?
Yes, sir.
Yeah, so you can speak in between as well. If you have any doubts, you can ask me concurrently, because in that way, if I also lag somewhere, I can able to look into it and let you know. So this is like that. Okay, next, this is the launch pad that we are going to see. So everything is written over here. So you can see from here that there is a 5-volt connection, there is a ground connection. This is for overall board. It is integrated into the every part of your microcontroller, whatever 5-volt and ground connection is required. Then you have your USB connection, this is emulation or UART, from which you connect your board into your particular software or IDE, that is whatever you say. So XDS 100 version 2 is a cable that you are going to use, emulation cable. After that, you have connectors. As I told you before, it is J1, J3, J2, J4, J6, J8, J5, and J7. So you don't need to remember all these things. Okay, it is there on the board itself. What kind of pin it is and how it is useful for you. That we are going to see in the today's session. That which board is used for what particular purpose and how you are going to configure that particular thing. Okay, from this side you can see, as I told you before, this is the main IC, TMS320F28379D, and this is an oscillator which is used for providing clock pulses. The maximum clock frequency that this board is going to work on is 200 megahertz. Okay, so 200 megahertz clock frequency, in the sense, what exactly that means? So that means that 1 upon 200 mega, that much of the time period will be there for that particular pulse. So that small time period you can pass 2 to the power 32 integer of data at a time. So you can imagine how fast that particular microcontroller is. Okay, so that is the meaning of that particular thing. Then you have here J21 connector, which is a ADC connector. As you all know, ADC pins are basically just analog to digital converter. What it does is it takes your analog signal, and when you put it into the board, you can sample it into different, different samples, and you can see if you want to perform certain other task on that particular data, that you can do. It is shown here differential input. There is one single ended input and differential input. Differential input means if your signal is on high potential and low potential, if two different potential are there and you have to insert that signal, then you can use this particular connector. Otherwise, what exactly is there is you just have a single ended input in which your signal will be at 5 volt plus and 0 volt ground. In that case, what you can do is you can insert directly into the inbuilt module of this particular microcontroller. Okay, next thing is this CAN bus. CAN bus is there in order to provide your connection of two or three microcontrollers together. Like if you want to say, let's say there is certain inverter such as multi-level inverter, there are many switches. So how we can operate those switches, how we can provide pulses to those particular switches if there are 12 in the number. So those many EPWMs will not be sufficient. In that way, what we can do after that, so to solve that particular issue, we can connect three or four microcontrollers in parallel. So we can use CAN. So CAN also has a, one high bus, one low bus, and then it has certain number of bits which will tell you how you can actually connect your particular microcontroller to another microcontroller, then how you can transfer the data and all those things. So that is the use of this CAN. Then you have here QEP J14 and J415. So this QEP is a quadrature encoder pulse module. As I told you before, it is actually based on detecting the, rising and falling edge of your signal, and it will detect the position. What actually happens is, let's say if your motor is running, now that motor is running, so what is happening is your shaft is rotating. Now if you mount any encoder on that particular shaft, it has three outputs: output A, output B, and certain other clock output. So what it does is, depend on that clock output, it detects the rising edge of that particular clock, and then it will keep an estimation of that rising edge with the next pulse, and that way it will calculate its speed and position and all those things. So this is for that particular thing. So there are different modules in this particular launchpad. So this is actually, one more thing is there is certain reset button is provided, S3, on this microcontroller. This reset button, let's say your microcontroller is hanged or something, so it's just like a turn on to turn off switch of your TV. You can press it on and off in order to make your algorithm, make your microcontroller into the reset mode. So it will be in reset and it will start as in a refresh mode. Okay, so this was the overall about this launchpad. Anybody has any doubt?
Sir, CAN is basically a communication protocol, right?
Yeah, yeah, it's a kind of communication protocol.
And sir, like previously I've worked with 8-bit microcontrollers, so over there they usually have RxD experience. So that CAN is basically a advanced communication uh,
Yes,
facility
yes,
for these
yes,
DSPs,
yes,
right?
yes, yes.
Okay.
So, if anybody else has any doubt, they can ask me. One more thing I forgot to tell is about this GPIO pins. You can see here there are three pins over D1, D9, and D10. So one is the power LED, green LED. GPIO 34 is a red LED, and GPIO 31 is a blue LED. So these two LEDs are given. Let's say you want to make a code for like when you learn any new microcontroller, what you do is you see first LED blinking code. So for that purpose, if you want to use any particular GPIO, so this particular two GPIOs are actually inbuilt for that particular purpose, and it is integrated in order to have that particular approach, so that if you want to toggle one LED and you can see what exactly is happening in particular microcontroller. So D9 and D10 is used for that particular thing, and D1 is a power LED, which is a green LED. Once you turn on your microcontroller, this LEDs will start blinking. So you can see key, as I told you before, there is everything in this microcontroller is a GPIO, that is general purpose input output. So this pin is also a GPIO pin, like it is actually a output pin since it is an LED. So when you assign any pin as a output, what it will do is it will give you a output, like it will start blinking in a red color, it will start blinking in a blue color. So what does that exactly means is, on that particular pin you are setting it as an output using certain register, and then that pin is blinking red or green or blue, whatever that pin is assigned for. Okay, so this is particular board overview which you need to know in order to program this particular microcontroller. Okay, so this is little bit theory. I'm sorry for the presentation, I didn't want to waste much of the time onto this thing. So what actually this microcontroller, as I told you before, it can be used in any real-time application, industrial motor drives, solar inverters, digital power, sensing and signal processing. So everywhere you can use it, and it is a 32-bit floating point processor. Okay, it has advanced TMU. Okay, so you can use it for certain complex mathematical calculations as well. Then there are certain set of cohesive softwares that is provided by this TI, such as software development kit, motor control software development kit. Now they are integrating more into this, like there is one thing called as CLB, which is a configurable logical block peripheral. What this peripheral actually do is, you must have heard about, there is one other microcontroller, that advanced microcontrollers are used for certain purposes, such as, let's say you want to generate and or signals. So that also you can do in this particular microcontroller with the help of CLB module. So if time permits, we'll look into that as well. So this is all about this particular microcontroller. So so as I told you before, it works on the clock frequency of 200 megahertz, and it has a TMU unit, it has a VCU unit, and whenever you want to perform any complex math operations, you have certain other accessible things as well. So we'll look into that one by one, how we can actually do this. So theory is just to have an overview to you, what actually you can do onto this particular microcontroller. But whatever we're going to see, we are going to see it with particular example, how we are going to have that particular thing into this particular software that we are going to see. Okay, so you don't have to worry about theory and all, you just have to understand how you can program this microcontroller. Okay, and little bit meaning of this things, what exactly this means. So this is a dual core architecture, as I told you before, 200 megahertz unit. You have a trigonometric math unit, floating point unit. Generally, these microcontrollers are floating point based in order to perform your complex maths, so that you can convert fixed point algorithms into floating point. Floating point processors are a little bit less cost, so it is used for that purposes. Then you have control law accelerators, which works independently of this particular microcontroller. Then you have EPWM as well. So it has 24 PWM channel. Then you have HR PWM, which are used for high resolution pulses. Generally what happens is, when you start increasing your PWM frequency, so if it is increased from certain hertz to, let's say, certain megahertz, what exactly happens is your clock signal or your pulse signal will become little bit overshoot will be there if you're trying to operate it on 200 megahertz frequency. So in order to avoid that overshoot and make your signal little bit clear, you use this HRPWM. It provides you 120 picoseconds of step resolution. What does that means? In 120 picosecond, it will rise to that one particular high level. It means that. So this HRPWM will give you, let's say you are working in power quality or something, and you don't want glitches in your pulses, and you are also working at a very high frequency. So in that case, what you can do is you can use this HRPWM module. Then, as you know, in this EPWM module, there are many things that you can use. There is one deadband support. Like let's say you have two PWM signal for high and low switch, so you know the use of that. Whenever there is certain let's say clapping of these two pulses, what will happen is your microcontroller, your particular DC bus will get shorted. So in order to avoid that, what we do is, since turn off of IGBT is longer, so we provide that particular dead band of time. What happens in that particular time is you will have you will have certain time in order to turn the next switch on. So to provide that dead band, you can use this particular module as well. Then there are certain, like PWM chopper is also there. Like if there is a high frequency pulse and there is a low frequency pulse, one is 50 hertz and another one is 1 or 2 megahertz, and let's say you want to chop your 50 hertz waveform into particular small setups on and off waveform. So what you can do is you can multiply these two with PWM chopper and you can chop your particular waveform. So all this we are going to see one by one, key what module is there, how you are going to use this particular module, and what exactly that means. Okay, so then you have ADCs, as I told before. Then ADCs are into two modes. One is 16-bit mode, another one is 12-bit mode. So how much data you can pass in one clock cycle? That is 1.1 mega samples per second, 3.5 mega samples per second. So these are the sample unit. You can sample this minimum. Let's say you have a 16-bit of ADC, you have a 12-bit of ADC. What does that mean? Let's say you have a 10 volt of signal. So what you can do is 2 to the power 12 will be 4096. So for any 12-bit ADC, then you can use this 10 volt into your 2 to the power 12 into 1 divided by 4096. So those many of timestamps will be there in each particular sample when you are going for ADC. So that also will look into detail. Then you have sample and hold circuit for each ADC, like single, separate. So what is use of that? That also we are going to see. Then there is certain PPB block, like post processing blocks after ADC conversion. Let's say you want to store your ADC data into certain registers, so you can use this PPB as well. There are certain algorithms which actually does this zero time detection. Like let's say you want to detect the zero crossing capture, that is also possible in this microcontroller. So it has provided with you a lots of features. Like in a less time you can perform any computation for your research. If you want to develop any algorithm, and if you have knowledge of this particular microcontroller, what you can do is you can just make your one algorithm, and you can make your particular system into existence, whatever you are imagining to happen. So whatever you imagine, you can particularly think to implement onto this particular board. Then there are certain DACs are there. DACs are used for like whatever signal you are taking inside of your board. If you want to output that signal, you can use DAC. So in that DAC you can see particularly what signal you are giving into the board. Is it the same signal that you are seeing outside the board? So you can use DAC for that particular purpose. Okay. So it is about the features of microcontroller that we are going to look into. So this I'll tell you now what is exactly this means. Okay, but before going into this, uh, okay, so till now, does anybody have any doubt in understanding features of the microcontroller?
Sir,
Yeah.
sir, as you mentioned that maximum clock frequency is 200 megahertz. Like
Mhm.
the frequency that can be generated at the PWM that differs, right, from the clock
Yes,
frequency.
yes. It differs. It differs. Like you cannot generate a, let's see, Father, you cannot generate a particular PWM of 200 megahertz. There are certain limitations. You can go up to certain frequency like 50 megahertz, 60 megahertz. But what will happen is, let's say कि microcontroller architecture is basically consist of many peripherals, right? EPWM is there, ECAP is there, equip is there. So this clock frequency at every stage is divided by a inbuilt clock divider. Okay, let's say your particular EPWM module is there, which is used for generating pulses. So this particular EPWM module, it is works on maximum 100 megahertz of clock frequency. It means that you can use it up to 100 megahertz, but not exactly you can produce a pulse of 100 megahertz, because every EPWM module is at 100 megahertz. But when you are going to generate the pulses, there will be lots of noise in that particular pulses, and it will be distorted. So when you're going to use it above 50 megahertz, you will see those problem arising. So the basic, we'll see what is the limit when we'll see exactly formula now. What is the formula for generating this EPWM pulses? At that time, you will understand what is this clock divider, and what is there are actually certain sub modules also this into this EPWM that we are going to see. As I told you, deadband is there, PWM chopper is there. Then there is one called time based sub module. In that time based sub module, certain counters are there. So how that counters are going to perform, so that time based counter also has its own clock. So it is limited to 50 megahertz. That's why your maximum clock can go up to 50 megahertz or less than that. So it is all like that. So all submodules work on certain clock dividers. Let's see, there are certain PLLs, phase lock loops, which are used as a clock dividers. See, when you are using main microcontroller at 200 megahertz, not all peripherals are able to work at that clock frequency, because when you are processing any instruction, you want to be process it at a very higher speed. But let's say you want to generate some pulse. In that way, what will happen is there is not only one work of this microcontroller to generate the pulse, right? It has to enable interrupt, it has to disable interrupt, it has to come in instruction wise to execute that particular instruction. So what exactly happens is there are certain limitations of that particular submodules. Like in this module, for generating any triangular wave, we use time based submodule. So that time based submodule is limited to 50 megahertz clock. So in that way, you cannot generate a pulse of 200 megahertz. Is it clear?
Okay, sir.
Yeah. Any more doubts? See, you're welcome to ask any doubt, okay? Because if I don't know about it, I will look into it, I will get more knowledge to you, and then I can transfer that knowledge to you, okay? So whatever doubts you have, you can ask me at any point of time, okay? So, okay. So this is F28379D board overview. Now we'll see what exactly your particular GPIO is. So your general purpose input output module. So as you can see in this particular module, there are two muxes, GP mux1, GP mux2. So why we are using this muxes? So let's understand it clearly, what exactly this figure means, what this qualification is, what this pull down register is, what data register is, okay, and what these peripherals are, okay. So I will start with the peripherals. This particular peripheral 1, peripheral 2, and peripheral 3, okay, these are EPWM equip or other peripherals. As I told you, every pin on this microcontroller is particularly a GPIO pin, general purpose input output pin, okay. So every pin can be connected to certain peripheral. Peripheral 1, you want to connect EPWM. If you want to operate any pin as a EPWM pin, you connect it to the peripheral 1. If you want to operate that pin as a equip pin, you connect to peripheral 2. If you want to operate that pin as a, let's say, ADC pin, you connect it to peripheral 3. So these are certain peripherals. So it is not particularly of F28379D. It is of certain other board. But in order to simplify the diagram and to tell you exactly how this operation happens, I have taken this screenshot. So you can see here there is one data register. It has three bits. One is set bit, another one is clear bit, and another one is toggle bit. So set, clear, and toggle. What does that mean is this GPIO data register is one particular data register. In this, these particular three bits are over there. Like if you want to set one particular register, if you want to put some value like 1 or 0, you can use this set. Clear means if you there is certain data into this particular GPIO pin and you don't want that data to be there, so you can use clear pin. Then there is one toggle pin. Like let's say you want to toggle that particular pin 1010, like we saw toggling of any LED. So these registers actually provide you the direct access of that data register. Generally, it is not preferred to use this because what we are going to program is to these two particular muxes, GPI mux1, mux2. And by using direction register itself, you can use that pin as a input pin and output pin. But let's say you want to toggle any LED directly. So what you can do, you cannot either assign it as an input or output. You want to toggle it. So what you will do is you will use GPIO toggle register. So these are two registers which you can program through. So mux1 and mux2 qualification is basically in order to set your quality of your GPIO signal. Let's say if any GPIO signal is generating particular time step, for let's say let's in HRPWM we have 120 picosecond of time step. Like in 120 picosecond, that signal can rise from zero level to higher level. So in order to maintain the clarity of that signal, how much glitches should be there, that is also adjustable to this qualifier selection. So you can use this qualifier selection for that particular, but generally The qualifier selection are not advised to touch. They are there and they are inbuilt on their best performance. So you are not advised to do any modification into that. Then you have pull up and pull down resistors. Let's say any GPIO is at a high potential. You want to pull it up at a low potential in order to enable it or disable it. So particularly you can use pull up and pull down resistors. Let's say there is certain pin at a VCC, but you don't want that particular pin to be high when it is not in use. So what you do is you use a pull down resistor in order to ground that particular input so that no other harm will be there. So this high pull up or pull down resistors is connected in between in order to limit your current to that particular microcontroller, so that your particular microcontroller will not damage due to any short circuit if also it happens. Okay, generally it is a very sensitive microcontroller. It also, like, even if you touch with your bare hands as well to this particular pins, there might be static discharge and that pin might not also work. So you are not advised to touch any of the peripheral on this microcontroller. Whenever you are going to use it, you have to hold it in such a way that it should not be touching your palm as well. Okay, so it is like that. So you can see here, when you assign 0 0 into particular GPIO, it will work as a general purpose input output pins. When you assign 0 1, it will work as a peripheral 1. When you assign 1 0, it will work as a peripheral 2. And when you assign 1 1, it will work as a peripheral. So these are the multiplexer control bits. So according to this particular bits, you can use it. Now, what is actually divided, like what multiplexer exactly we are going to access which pin? Okay, that we'll see now. So this will give you a clear view of GPIO and peripheral mux. So is this picture clear to everybody? Hello, hello.
Yes, sir.
Is this picture clear to everybody? Okay, if you do not understand something, you have to ask me. Okay, so I'll explain first. After that, you can ask me. So you can see here there are two muxes basically. One is Gmux and one is normal mux. So this Gmux and normal mux, what exactly it tells you that when your Gmux is particularly 00 bit, okay, it is assigned to 00 bit, and your normal mux is assigned to 00 01 10 or 11, it will have access to this particular feature. Let's say your particular Gmux is at 00, and now you are using normal mux as 00. So what it means is your pins are all GPIO pins. All GPIO pins means you can use it as an LED to output a pulse. You can use it as an input in order to put into a data, certain data into that particular. Or let's talk about this only equip. What we do in equip is we take outside signal, pulse signal, into the board. So in that way, in that one, what we can do is we can use direction resistor as 0, and then we can use that particular pin as an input pin. Then what will happen is whatever your signal from outside, that will go into that particular mode. So that will be a general purpose pin which is used as an input. So we'll see how exactly that happens. Okay, after that, normal mux, if you set at 01, then that particular pin will be working as EPWM 1A, 1B, 2A, 2B, 3A, 3B, 4A, 4B, and so on. So there are certain, these pins are only allocated to use as a GPIO pin, whether it can be used as a EPWM pin, it can be used as an output crossbar. What this crossbar is also, that also we'll see. Okay, so you can use this particular mux in order to configure your pin as a EPWM pin, GPIO pin, and so on. You can see here, I'll show you the register as well. So see, this is a normal register, A mux, and this is a, you can see the name of this particular register. It is GPA mux 1, and the other name register is GPA G mux 1. So this a normal mux and G mux, these are the two index that you select any pin, as you can see in this configuration. Okay, this data is available in the technical reference manual. I'll share it with you. So you can see this G mux. So in this Gmux, if you put certain data, it will work on that particular, allocated peripherals. If you put it as 01, it will work on that particular peripheral. So there are certain limitations also that we need to understand. So you can see here. So I'll tell you how exactly, which pin you can select and what exactly this means. So see, from this one, you can see that your GPIO module, it controls your input output multiplexing, sharing, and as well all those kind of operation that we saw. So you can see that GPIO, it is actually can be used with CPU1 plus CLA, CPU2 plus CLA. CLA is a control law accelerator, as I told you before. It can work in parallel with your CPU as well. Let's say your CPU is performing any task, then at the same time you can allocate certain tasks to CLA as well. But the coding of CLA is in assembly language, so it is a little bit complex in order to understand. But it has a direct access to those peripherals or registers, so it increases your speed. So that is the main purpose of this CLA. If you don't want any interrupt latency and you want to work at a very high frequency and you don't want any interrupt to come in between, so you can use CLA for that purpose. Okay, so we'll see, if time permits, we'll see that as well, how we can work with that. So you can see there are 6 port A, port B, port C, port D, port E, and port F. So these F ports are there, and every port is divided into 31 pins. It doesn't mean that this particular microcontroller has access to 168 pins. No, it is not like that. There are only 80 set of pins, from which there are certain pins which are allocated to certain peripherals, which you can use as GPIO, EPWM, or anything. If you want to use all the pins, then you need to buy certain another, extensive set of this microcontroller, which actually called as a evaluation kit, which actually allows you to use this particular all the pins, so that these pins are not actually like you need all those pins. It is not like that. When you want to buy certain evaluation kit, instead of that, people preferring, concurrent and parallel operation of those microcontrollers, so that you can have access to more number of pins. Okay, so you can see here your port A will be consisting of 31 pins, GPIO 0 to GPIO 31. Now this port A will be itself divided into MUX 1 and MUX 2. And MUX 1 will have 15 pins and MUX 2 will have another 15 pins. Like let's say 0 to 15 will be for MUX 1 of port A, and 16 to 31 will be for MUX 2 of the same port, like port A. Then you have port B. So 32 to next 15 will be for MUX 1, and after that 263 will be for MUX 2. So it is not like so every mux, like GPA mux and GPG mux, you can see from here it is divided into mux 1, and it will be also there will be certain another register which will be mux 2 as well. So it belongs to port A. So port A mux 1 means what pins will be there? GPIO 0 to GPIO 15. Understood? Similarly, for Gmux, you can see. So this GPA, A means it will be having access from 0 to 15. Why 0 to 15 only? Because 1 is there. So A will be having 0 to 31, but 1 will be having access to 0 to 15. So whenever there is combination of this A and MUX 1, you will have access to GPIO 0 to 15. So you can see here from this register, if you particularly, there are 31 bits, so you can program into this particular bit. If you put 00, this particular bit will get activated. So we'll see, when we'll see any software running, we'll see how you can actually, model this GPIO as an input, model this GPIO as particular output. Okay, and how we can use it for toggling LED as well. That also we can see. Okay, so this is about the GPIO. So from here you can see this is a GPIO logic for single pin. So what you can understand from this particular GPIO is, see, on the rightmost side, there are certain peripherals which are connected. It means that this particular GPIO can be used for any other peripheral. Then you have input crossbar. Input crossbar means, let's say you want to, get your signal into the board from the board itself. Then you can use this input crossbar. Like only transferring of the signal inside the board, then these crossbars are used. Then you have certain qualifier selection register. You have system clock to operate that particular GPIO pin. Then you have a data register in which you can directly access, and you can directly put your data into that particular GPIO pin. However, it is not advised to use your data register directly. Okay, we'll see why it is like that. Okay, then you have, I told you before, it can be used on CPU 1, CPU 2, CPU 2 plus CLA, CPU 1 plus CLA. Set, clear, and toggle bits are over here. Then certain peripherals are also here, which you can transmit your data directly to. Then you have a direction register over here. What with direction register you can do? You can assign that pin as an input or output. So that is only you need to understand through this particular microcontroller logic diagram. Okay, so, and now how we are going to select that particular thing. Okay, so you can see here this board overview is provided with a J1 J3 pin, J4 J2, J5 J7, J8 J6. So how this is related to, this is actually given in order to access your pin on that particular board. Let's say you want to access pin number 1 from J1 pin. So if you assign your mux value as 0, it will be 3.3 volt. Now you want to access pin number 2 on J1 2. So J1 pin number 2 is your GPIO 32 if you assign your mux value as 0. Which mux value I'm talking about? Normal mux, not the G mux. G mux has to be at 0 0 because from here you can see if G mux is at 0 0 and normal mux is at 0 0, then only I can use it as a GPIO. Otherwise, if normal G mux is 0 0 and normal mux is 0 1, then I can use it as a EPWM. So this is the normal mux I'm talking about. Okay, so gmux will be actually set it at inherent value as 0. If you want to change it, you can change it as per your interest. We'll see how to change it and how to access that particular thing as well, how to use that pin as a EPWM pin. We'll see that as well. So what I wanted to show from this is, let's say you want to access pin number 3 of your J1, so it will be GPIO 19. So what GPIO 19 can do, you can see from here. Okay, GPIO 19. Okay, it is lower bit down over there. You can see another thing. Let's say, let's talk about GPIO 0. Let's say J4 pin number 40 is GPIO 0 or GPIO 1, which can be used as a EPWM pin as well. So on this particular microcontroller, this is J2 and J4. So you want to access pin number 4 or 5. Okay, so here it will be return pin number 1, pin number 2, pin number 3, pin number 4. So if you see pin number 4, okay, so what that pin number 4 indicates on G4, 1, 2, 3, 4, pin number 37, it indicates GPIO 3. So what does that GPIO 3 can do? Then you have to look it over here. That GPIO 3 can be used as EPWM, it can be used as output crossbar, it can be used as SCLB, or it can be used as other thing. Okay, so it is like that. So if you want to access any pin from your J5, J7, this pin number will be written on the board itself. Okay, you don't have to worry about it. 31, 32, whatever pin number is there, it is written. So you can access that particular pin directly. As I told you with banana connectors, you can connect. It is written on the back side as well. Okay, so you can access that pin into particular thing. And whenever you want to program it as GPIO pin, you can use it as 0. When you want to program it as EPWM pin, you can use it as 1. So like that, you can have access to that particular pin. Is it clear from what I said?
Yes, sir.
Yes.
Okay, so everybody is cleared that how to access that particular pin. See, it is the integral part. If you understand this, you can understand coding as well. Okay, so you need to understand how to use that pin. If you are accessing that particular pin, okay, you can use it, and you can code also, you can do anything, but you need to see into technical reference manual ki what that particular pin is used for, what purpose. Okay, this workshop is not at all like other workshops where you will get theory knowledge and you will understand what. No, you will understand how to code it, and you will have your own exposure of coding. After certain time, you will be able to generate your own algorithms. So for that purpose, I want you to understand each and every bit of this microcontroller, whatever I'm going to tell you. Whenever I will show you code now, you will exactly understand what I was saying. Right now, it will be little bit tricky for you, what this Gmux is, what this Amux is, and why we are using it. But you just have to understand that every pin on this microcontroller is a GPIO pin, and we can access that pin with Mux 1 and Mux 2. Understood?
Yes.
Any doubts are there? How to select these pins, how to use these pins? Is there any doubt? Okay, I'll wait for 5 minutes. You guys quickly revise through. Okay, so that you can have understanding of what exactly this means. Okay.
Sir, basically this is about pin selection and its mode selection, right?
Yeah. It is about that. You can select any particular pin, you can use it for particular purpose. But it is necessary because every pin, when you need to access, you need to understand how to program that particular register. Okay.
Okay, sir.
Yeah. So any further doubts? Does anybody have any further doubt? Everybody understood these ports are there, these many pins are there. It is divided into two sections. Okay, it can be used for one particular purpose. Then uh, then there are certain pins such as ADC, how to access these pins as ADC as well, that also we'll see. We have comparators, you can use two signals for comparison. You can use DAC, you can use anything, whatever you want to use in this particular board. You just need to have an understanding how you can use that particular pin. That's it. Okay. So I'll give one more example if it is not clear. Let's say you want to access, this J874 pin and it is named as GPIO 14. Okay, so you can look into this particular thing and you can see GPIO 14 is somewhere over here. Okay, then it can be used as EPWM 8A. Okay, but you can see in this one it is not given as 8A. Okay, so in that way, why we are how we can use this is we can set mux value as 1. You can operate that pin as EPWM 8A. Okay, it is not like only 3 PWM modules are there and only 6 signals you can generate. It is not like that. Maximum up to 10 EPWM signals you can generate, and that will depend on how many EPWM modules are there, and it is given in this GPIO and peripheral muxing. Okay, so that particular J8 pin number 74 would be somewhere here, and you can access that particular pin directly with your banana connectors. So it is like that. And this is one programming logic. Like, see, these are the EALOW protected register. In this microcontroller, certain registers are EALOW protected. Like if you want to access that particular register, you have to write this commands: EALOW and EDIS. EALOW means allowing that particular register for accessing. EDIS means disabling. Okay, so you disable with this EDIS. We'll understand what this particular instruction actually means. Okay, so you can see here this dot you can see in between, it is a pointer. Okay, like you can see any pointer in a C language, it can be used for accessing the address of that particular bit or that particular register. So this dot is used as a pointer here. So there is one register which is GPIO control register. In this particular register, there is one other bit which is GPB mux1, and this B mux1, as you can see here, B1. B1 means what pin will be there? You can see from here. See this B. Port B will consist of pin number 32 to 63. But one mux number 1 will have 32 plus another 15. That is pin number 47. So 32 to 47 pin number will be accessible by this bmux. Okay, so you can see here pin number 34. You are accessing which bit of this particular mux? Pin number 34. Why only 34? Because it has access from this 32 to 63. So whatever pin after 32 and before 47, that will be accessed by your GPB mux1. Okay, like if you are using port C, it will be after 63. Okay, and if you are using mux2 here, then what will happen is B mux2, which bit you will be have access to? You can have access to 47, bit number 47 to bit number 63. So GPIO 32 you can have access, GPIO 34 you can have access, GPIO 35 you can have access. And what these pins are? GPIO 34, GPIO 35, these are J4 pins, J5 pins, J8 pins, J6 pins. Okay, so you want to access G1 GPIO 32. So it means which GPIO 32 is pin number 2 on this particular J1. Okay, so this J1 board has pin number 2. So you can use this particular thing. Okay, after that, you have a direction register. Now why this direction register is given? As I told you before, I have put GPIO 34 direction register bit as 1. It means this particular GPIO 34, it is used as an output. If it is 0, it is used as an input. Why it is like that? Because it is a direction register. And what output means? Output means this LED will be glowing now. You will see output on this particular LED. Okay, so you can see from this one. Okay, GPIO 34. Okay, this is a red LED. Okay, so when you program this GPIO 34, it is no more a pin, but it is a red LED. So what will happen is this red LED will start glowing for that particular period of time when you are using that particular LED as an input or output. Okay, so this is about accessing the bits of particular microcontroller. Okay, certain registers are EALOW protected, which is there in the datasheet itself. In that datasheet, which you can see which register is EALOW protected and which register is not. So when you type or when you code into CCS and when you type bit dot, automatically all the GPIOs will be listed over there, which is under the under this particular B mux1 category. You can easily select one of them and you can code on your own. So okay, so you don't need to remember every time and go and see which GPIO is in which mux. So when you're going to type gpb mux1 dot bit dot, automatically gpio 31, 32, 33, 34, so 32 to 63 bits will come over there. Similarly, in case of GPIO direction register, if you want to access particular bit of this register, you can select which pin you want to access, and you can use it value as 0 or 1. Okay, so it can be, binary as well, and it can be, you can also put it in decimal as well. We'll see how you can actually use it. Actually, this particular microcontroller has given a location that you can use it decimal values as well in order to particularly program it, or more accurately, you can use it in binary as well. If you put your particular value in binary format, this particular register will get programmed. If you put it in decimal format also, it will get programmed. So it is a ease for an user that one can have. Okay, so it is about the using and accessing of this particular register and configuring. Okay, so anybody has any doubt?
Sir, can you go back to that code part?
Yeah, yeah,
Sir, in this case, direction register is setting the direction of the pin, and
yes.
mux register should decide the value, right? So for the LED to glow, should the value be 1 or 0?
Okay, okay, okay. See. Actually, whatever mux you are using here now, it is
Yes, sir.
for the initialization. Okay, it is not for setting any value. It is for
Okay.
accessing that particular pin. When you are initializing particular bmux1 value, means you are using that particular pin as, as you have to access of that particular pin. If I put here GPIO 15, means I am accessing or I am initializing GPIO 15. Okay, so I can use that GPIO 15 as input or output with the use of direction register. Understood?
Sir, which of these statements will decide that LED is glowing?
Yeah, the GPB direction register equal to 1. This particular instruction will decide that your LED is glowing.
Okay, okay.
Okay, so the direction register, if you set it as 0, it will be input. If you set it as 1, it will be output. Okay, so your LED will be glowing with the help of this particular bit or particular instruction. Okay, so this bmux and all, it is just for the initialization or accessing of that particular pin. Let's say if I'm using GPA mux1 GPIO 32 or something, I can, access this GPIO 32 from here. So GPIO 32 is what? So I have to see it from this chart board overview. Like what is GPIO 32? GPIO 32 is J1 pin number 2. Then I can connect my, particular banana connector to J1 pin number 32 somewhere over here, and then I can see what is happening on that particular pin. Understood?
Okay, sir.